last unit, hopefully our last unit, is all about volume. Now, the difference between volume and area and surface area is basically the difference between two-dimensional shapes and three-dimensional shapes. Two-dimensional is flat, like the top of a desk or a piece of paper. A three-dimensional space is, well, it has some depth to it, like something that you can actually get a hold of and put your hands on it. It's got three different dimensions. It's got a length and a width, and it's also got a height. So basically what we're going to try and do is figure out how many cubic units, how many little teeny tiny cubes it would take to fill up a shape, okay, versus how many squares it would take to cover a shape. So basically it's the difference between a Christmas present, and the wrapping paper, right? The box or whatever it is that you're getting, that is the three-dimensional shape, and then the paper is what's used to cover the shape. So, excuse me, that's the basic idea. So I think this picture here is a pretty fair representation of what we're going to be doing. We're going to be trying to, sorry it's fuzzy, but we're going to be trying to find out how many small cubes make up the bigger shape. Okay. The nice thing about this, at least I think so, the nice thing about this is volume is much easier to do than surface area. The reason why volume is much easier to do than surface area is because rectangular prisms, triangular prisms, cylinders, those are all pretty much the same idea. Pyramids and cones, all pretty much the same idea. Now they're different shapes, but how we're going to approach this is going to be very similar between rectangular, triangular, and cylinders, and then pyramids and cones. All right, so what we have to do here is basically figure out what shape makes this what it is. Rectangular prisms are made up of rectangles. Triangular prisms are made up of, triangles. And cylinders are made up of circles. So what I'm going to do, or the way I've always kind of approached this, is we have one general formula, and we just swap out a piece of it depending on whether we're doing a rectangle, a triangle, or a circle. So the base is the defining shape of the figure. So a rectangular prism's base is a rectangle. So when I ask you to find, what's the area of a rectangle for a rectangular prism, the area of this is going to be length times width because it's a rectangle. And then you just multiply that by the height. Now, when we get into triangular prisms, that L times W, I'm going to trade that out for a different formula. When it's a cylinder, I'm going to trade that out for a different formula. But then the height part of it, how tall is your prism, that's going to be kind of consistent between the three. So what I've got here, if you take a look at this shape, on the bottom, I have a layer that is 2 units wide by 7 units long. So the area of that rectangle, I'm sorry, I misspoke, 2 by 4. The bottom layer of this box is a 2 by 4 rectangle. So that is an area of 8 cubic units, because they're cubes, not squares. So cubic units. So I've got 8 cubic units on bottom, and then I've got 7 layers of that, one on top of the other. So this winds up having a volume, right? I did 2 by 4 there for that area part of it. And then the height of it is 7. So what I wind up with is 2 times 4 is 8. I wind up with 56 cubic units on this. Okay, so like the last one, when we did square units, we did SQ, and then inches, feet, miles, whatever. We're going to do CU. Feel free to write out the whole word cubic if you want, but CU, inches, CU, feet, CU, miles, whatever. Excuse me. Okay, so these are all pretty similar. We're going to find the volume of that kind of bottom shape and then multiply by how tall it is. So this guy here has a base of 7 by 15, and then it has a height of 4. Okay, so grab your handy calculator here. 7 by 15, and then times 4. This thing has a volume of 420 cubic yards. All right, same thing over here. That bottom layer, what it sits on, has an area of 6 by 18, and then it is 16 inches tall. So that is 1,728 cubic inches. Now, there's no hard, fast rule that like volume is going to be more than surface area is going to be more than volume. It really doesn't matter. It kind of depends on the shape and the measurements. But I want to stress on all of these, your units are cubed is a different type of measurement. We cannot use the same measurements. We did square inches for so long that I'm going to give you guys some leeway on this one, but we're switching gears. These are not square units anymore. Okay, last couple of examples here. Bottom layer is a 2x10. The nice thing about these is it doesn't matter if you switch up your measurements. You're still kind of doing the same thing here. This guy's going to have a volume of 100 cubic inches. So if I did say 5x10 and then multiply that by 2, that's what I mean. You can shuffle up these measurements and it works. You can do that on the rectangular ones. You cannot do that on the triangular ones. The triangular ones, you specifically have to work with the triangle and then multiply by how tall it is. All right, so last one here. This bottom is 6x3, and then it is 8 feet tall. It's a big box. So 6x3x8 is 144 cubic feet. Okay. Homework's a form, just like we've been doing. So, kind of find your rhythm with these and just make sure you type in your answers with the units, please and thank you.